Okay, so I'm just going to talk a little bit about the fundamentals of game AI to explain a little bit what kinds of things are we doing, a little bit how do we do it, but I don't want to get too much into that. I think it's more relevant to explain. I mean, the people who are in this field, of course, they already know. I think it's more important to explain like what kinds of things can we do rather than how do we do it, such that we can explore how might we collaborate, right? What can we do for each other? So I want to go to the 1950s. So I think some of our friends from working group 2, if they have a paper from 1950, they might refer to that as a recent publication. But for me, as a person from AI, this is what I call ancient history. That's kind of where my field started. And already when the field of AI research started, games quite quickly became important benchmarks for AI. So throughout the lifetime of AI as a research field, games have always been important. Yeah, so if we go back to these 1950s, there were probably some computer scientists and mathematicians, and they were thinking like, okay, we're going to do artificial intelligence. We're going to build some new intelligence. How do we actually measure what is intelligence? And they said, yeah, like they looked around the room with the computer scientists and the mathematicians, and they looked at each other and they were like, yeah, we are intelligent. We are the most intelligent people we know. And what do we do in our lives? We like to play chess. So how do we measure intelligence? We measure this by tracking the ability to play chess. And there was one in the image there. It maybe suggested, let's ask some people who have thought about this before, right? Maybe psychologists or philosophers. But he was defenestrated. And so this, yeah, I really like the word defenestration. So I had to get that in. So maybe that would have been a good suggestion, and along the themes of cost actions and interdisciplinary research, right? Maybe that's what should have happened, but it didn't happen. So for many decades, chess was this kind of, the ability to play chess was this kind of benchmark for measuring intelligence and measuring artificial intelligence. Yeah, so what kinds of goals do game AI researchers have? And I've talked about this a little bit previously, but now there's a slide to go along with it. Many AI researchers have often been interested primarily in these sorts of things: strong play, superhuman play, optimal play, if we can do that, but optimal play that gets more into the territory of mathematics maybe, and yeah. And ideally for many different games. So chess, for a long time, chess was the benchmark, but eventually we beat humans there, and then we shifted attention to Go, and then we shifted attention to some very complex video games. So sometimes this changed, but there was also this community of general game playing researchers and people who are like, okay, if we want true intelligence, we don't want to look at one game at a time, right? Because then we're just maybe even more measuring how smart are we as programmers, and our measuring our ability to inject good knowledge about these games, individual games, into the system. But artificial intelligence, we want to avoid injecting too much knowledge. We want to, so we wanted to be able to handle many different games. Games, maybe they're a guilty pleasure of AI researchers too. So game AI researchers in public, right? We say, okay, we do research on games because they make for good, reliable, safe, suitable benchmarks for decision-making algorithms, right? And in these games, we can have a decision-making algorithm. We can have it deciding what moves to make, for example, and we have a clear win or loss at the end, so we can reliably measure the performance of our algorithms. And if we have algorithms that work well in these games, then maybe afterwards we can shift and we can apply them to what everyone's always talking in AI about, real world problems, right? What's a real world problem? I don't know. But more, yeah, people are sometimes a bit scared of games. Are games important? Are they only fun? So we have this kind of excuse, right? We're testing it on games, but then we're gonna use it for actually important things for civilization. That's what we say in public. In private, we say, yeah, we just spend our entire lives working with these games because it's fun and we like these games, right? But that's what we write in the grant proposals. Thanks to maybe the digital looting project before this and now also GameTable, we can also actually claim that games are a real world problem too, right? Games, they're important for cultural heritage. So we have to develop AIs that can play these games actually such that we can contribute to cultural heritage. So also big thanks to that. Now we no longer have to apologize for working with games. We can say, yeah, the games are really a real world problem themselves too. Thank you. Now I'm getting slightly into how do we do what we do, right? What kinds of algorithms, what kinds of approaches do we use? So yeah, so this is an empty tic-tac-toe board, and we're really building on what Lisa already explained in the previous little talk. This idea that we're gonna have there are supposed to be pieces there. Did you convert it into a PDF? Okay. So imagine there are pieces on these 9 boards, right? And tic-tac-toe, you have 9 legal moves. So you have 9 cells, and on each of them, you might place your piece. So starting from the empty initial board state, you have these 9 options. So you're just thinking ahead, right? This is thinking one step ahead, thinking of what move can I make. If you do that one pie further, and I've only really drawn the edges and the subsequent boards for the middle thing because otherwise it doesn't fit, right? But for each of these boards on the first level, you can again think, okay, I have made one move. What can my opponent do next? Then you get a second level, and you can keep going like this, right? You can just keep going all the way until the end. And if you do that all the way until the end, then we call that an exhaustive game tree search, that you've really exhaustively searched all possible options. And we can do this easily in tic-tac-toe. There are some people who claim that there are more interesting games than tic-tac-toe. And many of those are also bigger. And in these bigger games, we can no longer afford to do that. Even with today's computers, right? We can not even get close to searching this entire space in a game like chess or Go or even smaller games, and definitely not in larger games. So what we have to do in practice is we have to limit the depth of the search. We only search a little part, and we don't end up in final positions, right? Because we can't search all the way until the end. So we end up with our search, we cut it off at like some point halfway through the game, for example. And then we have to have a function there that actually gives us an indication of how good is this state, how close are we to winning. So you can imagine in a game like chess, you're going to count the pieces that you have of all the different types and get some idea of the material balance. And you use this as an indicator for, okay, am I in a strong position? Am I in a weak position? Apart from limiting the depth of the search, so having this horizontal white block here, we can also limit the breadth of the search. So you no longer so maybe you do still search all the way until the end, but you don't do it for every single option at the top. And in practice, we kind of want to do a bit of both. We really only want to search a small triangle. And really in practice, we don't do it actually in this nicely shaped triangle, but we kind of smoothly adjust things. We'll quickly get an idea of, yeah, this area doesn't look too interesting. It looks like we've blundered early on. We're gonna stop searching here. And some other area, oh, this looks promising. We're gonna search a bit more deeply here, right? So in practice, we like to have this kind of smooth, uneven area where we search promising areas of the space more deeply than ones that are obviously like blunders. Yeah, so this is all about search, and search, my analogy for search is like a human player who's like deeply staring at the board and deeply thinking of this current position, and really the human is in their head really processing what are my options, what would I do, how would my opponent respond, right? Outside of these kinds of tree search algorithms, we also use reinforcement learning. So and the analogy for that is like training instinct, training intuition, and you do that based on experience, right? So search was really looking at the current state right now, deeply thinking about it. And learning is more like you gather experience throughout the years of playing this game. You build intuition, you build instincts, you learn to recognize patterns, and you immediately recognize, oh, in this kind of situation, I have to do this. And it's really powerful to combine these two things. We like to have both search and learning in practice. Different thing, explainable search and RL. So in explainable search and RL, we take these algorithms that I've just mentioned, we take these learning approaches, we take these searching approaches, but now can we extract explanations from that? Can we not just have a machine playing this game well, but can we also have the machine explain to us why is it making the decisions that it's making? Why is it not making a different decision? That sort of stuff. And yeah, because I'm talking about fundamentals of AI, that's not just AI for decision making. It could also be procedural content generation. So hello, working group 3. Yeah, so that there we also use a lot of AI. Actually, similar techniques, maybe less reinforcement learning, maybe more other flavors of machine learning, but also search. It's just at a higher level of abstraction. You have different goals. You're not looking to win this game, but you're looking to generate a good game, but that's still a more abstract space in which you might be searching. So there's actually a lot of overlap in algorithms we use, just a different signal at the end. Yeah. So that's all that I wanted to, I don't want to get into any more details than this. There's just a little bit of how do we do what we do and what do we do. Connections with working group 3. So connections with working group 3 are obvious due to the overlap and techniques used. Also, actually, we often use each other's work. Like if someone's doing procedural content generation to generate a new game, they like to have AIs playing that game to test, is it a good game? And the other way around, with if I'm building an AI that wants to become good at playing, well, for example, a video game, I might procedurally generate levels such that it can learn in these different levels. So it's not just an overlap in techniques used, but also actually really we use each other's goals as well, let's say. Connections with working group 4. So it's interesting, Lisa actually had a very different connection in mind than what I've put on the slide. I put on the slide that, yeah, like many of the algorithms that we use really have their fundamentals in mathematics. So in mathematics, I might really be looking at how do I optimally solve a game, and we take that and we make it we make an approximation of it applicable in practice to larger games. Yeah. Connections with working group 2. This is the one that's less obvious, especially to people who haven't been working with each other for a few years on the digital looting project already. Yeah, so for example, with this search for plausible rule sets, right? We're never going to be able to definitively say, oh yeah, this was the rule set that was used for a game. But we might have hypothesized rule sets and we might want to evaluate them and assign some kind of some kind of a label of plausibleness to it. Is this rule set more plausible than the other one? For that, we might want to use playtesting. We might want to use AI players for playtesting. If we have hundreds, if not thousands, of hypothesized rule sets, we're not going to find humans who are going to playtest all of them. We want to use AIs to do this. So there are a few challenges from the AI perspective for this. I think one thing is the large scale. Often when well, it depends. If you can take really you can start looking at one example of a game as a case study and deeply start studying that one game. And then the scale is not too bad. You just have this one game, maybe just a few hypothesized rule sets, then we can implement those. And and build good AIs for them all. But if we want to do this at a large scale for all these games for which we have unknown rule sets, or sometimes even just a single game where we have hundreds of plausible or like hundreds of hypothesized rule sets, this quickly becomes a very large scale, which is problematic in terms of purely logistics, like running our experiments, making all our AIs playing all these games, but also just implementing all the games actually. Like when the scale becomes big enough, you don't want to have programmers have to really make efficient implementations of all these games. You want to do it in a system like Ludi, where it's easier to put them all together, for example. Yeah, and the big one I think it's this idea of human playing experience. Can we actually mimic that with AI? For that, I think for now we have not been using human-like AIs. We've just been using the AIs that we have, which are just trying to win. And there are also sometimes, depending on how complex the game is, you either very quickly get optimally playing AIs if it's a small and simple game, or as soon as it grows into a slightly more complex game, you quickly just get very bad AIs. And it's you don't always get something in between. So even when they're just trying to win, even if you assume that's correct, which probably it isn't, then you also get like, how good should they be at trying to win? Should they be doing that optimally? Is it fine if they're doing that poorly? But yeah, so also I think we need human-like AIs. As I've mentioned earlier today, maybe we want drunk AIs if we know that this game was played in a tavern. We want them to have etiquette. Walter talked about that, right? We don't want AIs that are annoying and just keep playing back and forth. We're going to see that in a case study later today. We actually had that happening. Should they be playing for fun? And if so, how do we quantify fun, right? If I very quickly get back to this and where I said we need functions here at the end. And I was explaining when we want them to try to win, right? And then we use, for example, material balance in a game like chess, such that it tries to win. If we want to use the same techniques, but we want them to play to have fun, then we need to mathematically quantify what does it mean to have fun, such that we can put it in a function at the end of the search and back that up. How do we do that? I don't know. Hopefully we're going to figure that out over the next 4 years. Yeah, and I think with all the different games that Working Group 2 is going to be providing us, they're going to be providing us with data. And every time the data is going to be very different. Sometimes you have the social context in which it was played. Sometimes you have by whom was it played. Often you probably don't have two equally skilled players, right? Maybe it's often played between parents and their children. So now we don't need just a human parent-like AI, but we need a parent-like AI and a child-like AI and have them playing against each other. Yeah, many different kinds of challenges that we need to think about there. I didn't put a slide for the connections with Working Group 5. I think the connections with Working Group 5 are kind of similar across the board. We all want to improve education. We all want to disseminate our work. So I think that's the same for all groups, really. Yeah. This is who to complain to if you think we're doing something badly. This is the Google group. You should be joining if you want to be kept up to date on what we're doing. And remember, we have our first big meeting on Wednesday. Many of the people here know about this and will also be attending, especially people who are in this field already. If you're coming to this event, right, it's in a different building. I've mentioned it in multiple mails. Walter's going to mention it tomorrow again. I think at least one person is still going to come here. Hopefully not. Yeah. I think that was my last slide. Yeah.
Thank you for that. So I'm just curious to know how this works in practice. I, for example, have research projects which could benefit from some AI investigations along the things you just outlined. So is there any kind of infrastructure in place for making this collaboration happen? I mean, like these things have to be run on computers and software, and how do you envision this taking place?
So there is the Ludi vision, and I don't know to what extent, Eric, you still believe in that one. So in Ludi, the intention was, right, that this is going to be a framework, and we do have user interface there. We do have dialogues where if your game is already implemented in Ludi's language, you can load that game. You have drop-down menus selecting AIs. You can make them start playing between each other. You can make it collect a bunch of statistics on things like how long do these games last? Is there a bias towards player one versus player two? So that was the vision there, right? That there is this convenient software package with a nice user interface. And personally, I believe that you really should be approaching it on a case-by-case basis, because the types of historical data that is available is so very different for every different case. I don't think it's realistic to build a single software package that can absorb all these different kinds of, like every new game we look at, oh, this is a new type of data that we hadn't accounted for yet. So I think you should be looking at it on a case-by-case basis and really also be collaborating. It should, you need someone who knows about the humanities side of the question, and can check, are we accounting for all the information that we have, and are we not assuming any information that we don't have? And I think at the same time, you need someone who knows what's going on with the AIs, because there can be very subtle details of how are these AIs working. And I think you should always try to combine both areas of expertise.
In reality, it just depends exactly what you want to do. If you just want to model your games, as a non-computer science people, Ludi would be a good thing. I can show you that tomorrow. But if you want to run like extensive experiment on it, as you just said, with a really detailed metrics, all of that, Ludi could not be the best tool for that because it's general. It's not like specific to one game or one rule set or whatever. So just it depends exactly what you want to do. If you just want to see if your game is playable, Ludi could do it. If you want to design new games, Ludi could help you. If you want to see if some rule set that you find with some evidence, whatever, could be implemented and could work, same thing Ludi can say. But if you want to analyze if, I don't know, your game can finish for some weird rule set that you find somewhere and you want to know the optimal way to play to it, etc., 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 in that case, I will be in the same opinion of Denis. We will need something more specific than Ludi. But we will know a little bit more tomorrow, but I will try to motivate discussion with it.
Yeah, like one of the concrete issues, in my opinion, is right. Like in this user interface in Ludi, we have this drop-down menu where you can select between, I think they're ranging from like very weak AI to very strong AI, but those are just names. And in practice, even the very weak AI is playing optimally if you give it tic-tac-toe, and even the very strong AI is playing almost randomly if you have a sufficiently complex game. So these labels are too simplistic, and that's where you would want someone who knows about the AI side and can actually check, like, oh, is it actually what kind of AI do I need in this case, and do we even have an AI suitable for this, or do we need to implement a new one?
So I have some observation and question. Maybe just one first observation is a funny thing is that games are often used as a metaphor or as an example of social science theory. Like for example, Goffman that studied board games before he developed his frame analysis theory. And so it's for exactly the same reason for game AI study, which is choice function and repeatability. So that's really funny that it's a common space. We can maybe base ourselves on it to develop cooperation between the two fields. Also, just to give example of things that on top of my head, I thought about the overlap between G2 working group 2 and working group 1, is that chess was often used as a performative games. It's to show that you are part of the gentlemen, you are knowledgeable about things. It's a game often used to show that you are intelligent, things like that, at least in Europe. And what could be interesting is to see what were the games that were used by mathematics and all mathematician and also AI developer to show that it is intelligent. They don't do that with tic-tac-toe. They do that with chess. They do that with high mind games, but it's not as necessarily the more complicated games, in fact. And also the second point I can see is teaching advising. Often when when you are playing with someone which is who don't know the games or is less good at the game, you are often giving advice, but not always the best advice, or not always a specific advice. This is the best move. You often give indication because you still want to win. But you also want challenge. You also want your opponent to improve. So that could be also a field to explore. To how can we make AI that can give advice when playing against us, and adapt their play or their advice to the skill of the opponent. I don't know if it's possible, but I think it could be complicated, but also could be something to explore.
I think that there was some AI work on like trying to adapt your skill level to an opponent and this this sort of thing. Yeah, but I imagine they would have tried that with things like chess. But an important relation then back to human-like AI, right? Human-level AI is not the same as human-like AI. So I don't think that's what you were saying, but that's maybe among the AI people, they will sometimes conflate those two. Yeah.
Thanks. AI seems to me to be currently a buzzword and very popular and probably ill understood by people like me. So could you please give a definition of game AI?
Can I narrow it down to game playing AI? I mean, for me, game playing AI would be AI that's just trying to select which moves to make to play the game, and then for whatever objective you have in mind, which historically has been trying to win. That's something we want to swap out for a different objective, but yeah. So I know it's very annoying nowadays in the news. Everyone's talking about just the language models, and they say that's all that there is to AI, and yeah, that's not what we're doing. Although there is some overlap in techniques used, right? For the learning part, right? Not the search part, but this learning to recognize patterns. There's a lot of overlap there and techniques used behind the scenes, but for a different purpose.
You mentioned on one of the slides the issue of having fun. So, and I think in the morning it was mentioned that psychology is ill-represented in the project. And sure, I mean, game AI had some had some early start with the growth and all that kind of stuff, which try to understand how human play chess and stuff like that. But I think game AI people lost quite a lot of connection with the psychology part of the game playing. Perhaps the game design a bit more connected, but I think for this GameTable project, the psychology part is really relevant. I mean, it's very difficult to define what is a good game set without considering the sociology, psychology side of it. And I really would welcome if some people know more about the research which probably exists some extent in the psychology of games, and I think that would be useful to have a bit of more window on that.
Yeah, definitely. Although I think also that that the people who are looking at this from a game design perspective and trying to design games that are fun for human, that's again a different challenge from making the AIs have fun.
Can I, Dennis, can I actually answer this to
Yeah, of
my
course.
expertise anyway? What we're talking about, board games, usually it is playing to win, but there's a whole area of AI research on game AI research on playing to be believable, playing believably, right? So it's usually not in these kind of like min-max problems. Again, not all board games are like that, but a lot of research has gone into again, believable behaviors, and that could be done from human data, done from playing by example and things like that. So there is research on this, not necessarily covered in board game research, board game AI research, but there's stuff there, a whole genre of game AI, game playing AI that is not just to win, but to.
But I was thinking
Sorry,
more.
go ahead.
I mean, I'm more or less aware of that part, that line of research, and even if I haven't read all the papers and I don't know all the techniques, but I haven't had a very good view on the psychological from the side of psychologists. So we have an idea of, well, we try to measure that, okay, is this the distribution of moves is close of that of a human, and we measure that and so on. But I don't think that this is the experience of human is about.
Okay, sorry. Last time I'm talking. I promise to give this back. So there's a field, there's the field of effective computing, which is basically modeling human experience more broadly, right? Which is looking at manifestations of emotion, looking at annotations of emotion as in like, I like this game more than the other game, right? And then building predictive models for that. So that is a different topic, which is adjacent, and we've looked at, for example, in my lab, but not necessarily how rules, but how game events impact, affect, as in like arousal, valence, more, psychological constructs, right? Or their manifestations. So there's some research there as well. You might be more interested in effective computing than, let's say, hardcore game playing.
Okay, I'm not a psychologist, but I'm teaching educational psychology class, and at the end of each class, I am giving a final assignment as developing board games depending on the cognitive development skills of children, let's say. And we are testing and we are playing as a whole class. I have a rubric to test some specific things, but overall, I can say that to be able to understand if it's fun or not, the only way is play it. Okay, of course there are some researchers, but after you design something, you apply something, we should let people play and we should test if it's fun or not in some way. In theory, you can say that, oh, that's fun, but in practice, when they play, that may not be, I don't know. Right?
Yeah, I wanted to add exactly on what you're saying, because in a way, and I think maybe the field of affective computing can give some answers to it, because fun is very subjective. People know it when they have it, and they know it when they don't have it. So I don't think it's necessarily, maybe I'm completely wrong because I'm just an archaeologist, but I'm not sure if this is the right question to answer through an AI, but the other way around. So board games are maybe very difficult to gather so much data. So then why not gather the same data from video games where, I don't know, that you have infinitely more gameplay, and you can also just ask after every game someone, was that game fun? And then you do a giant analysis of all the different games that have been qualified as fun or unfun, and maybe you can shift the question for the AI driven question into qualifying certain board states as good or less good, especially with games that are random. And AI can, like with backgammon, you can always say there was a series of unlucky rolls that made the game be unbalanced or whatever. I don't know, again, because I'm not I'm an archaeologist, but I'm not sure if the fun is exactly the right word to ask there for the AI, but rather feed the AI fun data, and then that can qualify maybe what is fun. That's what I've got to do.
So, okay, so on the what is fun, I called to mind, I think the effective computing thing is going to be very important. I'm called to mind a quote from one of Jason Shearer's books where he was interviewing people who work on AAA video game designs for years. And they say, we never write a script for the whole game because we have no idea until we spent 3 years developing the game, what's going to be fun. So it's a big, huge question. I'm also reminded of a quote in Board Game Geek about bots, AI, cardboard AI for playing games, where somebody said one of the rules is the bot must not have more fun than the human.